So in this third video, we're going to talk about how you might go about actually sampling different communities so that you can collect some robust data which will stand up to hopefully some decent stats analysis as well. And for that, you need to design it well from the very beginning. So we're going to cover some aspects which I know that I've already chatted through with the ecology students, but I thought that the revision would be useful for you, and for the environmental science students I wasn't sure whether or not you'd really covered this, so I thought let's just discuss this all together, and sets you up nicely for doing further field work next year and onwards to your dissertation if you're ever doing anything that involves quadrat sampling. So there's two questions that are associated with this little video, and these are and they are, as for the others, exactly the same as on your quiz. So as for the others, I would say get your answers to them ready and go into the quiz already and set to write your answers down. And so starting with the basics, I guess, is, why ever would you use a quadrat to sample, for example, that hay meadow versus that silage field? Well, it just provides a standard sampling area. If you want to compare the number of species, then obviously you want to be sampling the same area. And quadrat doesn't have to be square. It can be circular, it can be any shape as long as it's a standard area. What you can also have is have it so that it's subdivided like that. That's actually very useful for counting within a quadrat, and I'll show you in a moment just how that might actually be useful for doing an objective measure of abundance. So talking about species abundance, there are two measures of that. It's how frequently something occurs and what the amount of it is where it does occur. So the area, in the case of a plant, it would be the area of that ground occupied by that plant. And we tend to do it as viewed from above, because plants being photosynthetic, that's actually very relevant to them because they're receiving light largely directly from above. And I'm going to, in the next slide, show you the difference between frequency and cover visually, because I think that's actually a really easy way of conveying that. But just to note before I leave this slide, that both frequency of occurrence and cover can be measured subjectively and objectively, and I'll come back to that after the next little picture slide, which is this one. And this just shows you the difference between things that have low cover and low frequency of abundance and versus high of both. So in the top left hand corner, we've got your classic rare species. It's got very low frequency of occurrence, it hardly ever turns up, and when it does, you don't have very much of it. So bee orchids, for example. At the other end of the spectrum, down here, you've got something like the daisies, which are always everywhere. You can hopefully see this is a bit more shaded in grey, supposed to represent lots of those little dots. So they're in every quadrat in abundance, so there's lots of them. So these are the sort of things that nobody worries about really, at the moment at least, in terms of conservation, because they are so abundant, and they're often also the species that are very important for other species because they're so abundant. Then you have the two intermediates. So you can have a low frequency of occurrence but a high local mean cover, so there's lots of it where it occurs, and so it tends to occur in clumps. So clump forming things like this cowslip that you've got here tend to do this. And then you've got the thing that happens where you've got a species that tends to occur quite a lot but is never very abundant. And so, for example, bugle is one of those. It just dots itself around, and it's just its nature is that it tends to be quite a good disperser, but it's not a good competitor, and so it sort of plays that intermediate game and ends up being frequent but never very abundant. So back to how you might actually measure abundance. Now, if you go for objective, going, wow, that's it, objective is much better than subjective, I know where I am, it's very time consuming, that's the thing. And that can mean that although you're getting a measure that seems more objective, if it's taken a long time to do it, then actually that becomes a problem in itself. So if you're looking at frequency of occurrence, then that's where these sort of little squares come in handy, because you can just count how many of them has got the species in, and so that gives you a measure. And then Cover, that tends to be even more time consuming. The most obvious thing to do, of course, is to just crop it all and dry it, and then you've got a perfect measure of how much of it there was. But obviously that means there's nothing left in the field, which in many situations is not ideal and will get you into a load of trouble because it's destructive sampling. So that's one possibility, but it's rarely done, it has to be said, in ecology. And the other thing that is often difficult to do is density, so you actually count the number of individuals. But for so many things, for example, the grasses, you don't know where one individual stops and another ends and another starts. And the same, for example, a cowslip. I mean, you know, that bunch, is it all one, or is it loads of them? What do you do? So it's all very well if you're doing something like orchids, then that's really handy because those you can do that way. But for many things, especially communities, it just doesn't work. And then the final one, which is basically an instrument of torture, I think, is to use a cover pin frame. I've never actually used one of these. I've seen it done. It's incredibly time consuming, and what it consists of is you've got these little pins and you're dropping them down, and it's as they touch each plant, and you can drop them down through your vertical zones and record each of those little touchings all the way. You might be there sometime. And that can be a problem, you see. It's one of the reasons I don't work with them, because you end up needing to have enormous amounts of time, which means you can't do very many quadrats. And many times, as an ecologist, what we need to do is to sample a large number of quadrats to see an overall pattern. So we usually use subjective measures. So for frequency of occurrence, one that is really quick and easy and gives you just a very quick broad idea of how much there is the Dufour scale. So that's this one here. And then often people use more fine scale, so a little bit more precision in there, and that is where you use one of the methods of actually measuring cover rather than just frequency of occurrence. Often it's percentage cover. I usually use percentage cover. I like percentage cover a lot. It's well worth noting that it doesn't have to add up to 100%. Well, it has to add up to at least 100%, including any bare ground, because there are no actual vacuums in that system. So if you've included bare ground and it's not 100%, you've missed something out, and that's actually very, very common. So watch out for that one. But it can be a bit more if species overlap. So percentage cover is a straightforward and widely used technique. The alternative that often people do use is the Domin scale, and I'll show you that here. So instead of thinking about whether you've got, you know, your 51 or your 60 or your 65 or your 75, it's all Domin scale 8. And then at the fine end, it divides out. So when you've got less than 1% cover, it divides out into one or two or several individuals. And it's especially this fine edge, fine end here, that people like, and the fact that this is supposedly quicker because you just do a big old grouping. So an advantage is that it's quicker and it gives you a little bit of a standard differentiation between different species, between different levels of cover at the fine end. Personally, I find the disadvantage outweighs that, which is that if I want to do statistics with this, I need to transform these data, and there's no very good way of doing that, something called the Bannister correction. But it means that I've compromised my data from the very beginning, and also personally, because I use percentage cover a lot, I don't find it faster. And down below the 1%, which is actually a significant area of cover, I divide it out into 0.5 and then 0.1 to mean tiny little smidgen. So that's a personal opinion. So you're very welcome to, in your own designs, choose which you think based on your own assessment of the situation. The other thing that tends to become something that is your own assessment is the quadrat size. I mean, that is kind of a rule of thumb, and it's all down to what is the convenient size for you to be able to work with. And it comes down to the size of the plants, really. So for really little plants, if you're trying to score them, their percentage cover, for example, in a biggish quadrat, it becomes really hard to do. I have a go sometimes, it's really hard. So for the very littlest plants, people tend to use the smallest quadrats. For most things, grasslands and heathlands, we tend to use 1 by 1 metre or 2 by 2 metre quadrats, because bigger is simply harder to get get your eye in. And but as the vegetation gets bigger, then the quadrat size gets bigger. And with woodlands, you can either have really big quadrats, which are hard work to set up, or you can do this thing called plotless sampling. Then there's how do you distribute your quadrats, and there's a variety of ways of doing it. I've listed some of the obvious ones that people use most often here, and I'll talk in particular about the first two because they're the ones that I should think that you'll end up using like at some point or another within your university degree, if not at several points. So one is random sampling and the other is to use transects, which is particularly useful when you're sampling along a gradient. And so imagine that this is Arn that you've got, and imagine that we're standing out here on this lovely peninsula, heathland, and then gradation down into saltmarsh. And we want to do a community analysis of these. So what would we do? We would do random transects or random quadrats or transects. Well, when you're looking at the gradient, you want to see how that species distribution changes as you go from heathland to the saltmarsh through the woodland here, then actually a transect is a good idea. You can still do quadrats along that transect, but you put them all in a line like that and you see how it changes as that environmental gradient changes. Whereas if you're sampling what's effectively a homogeneous area, so it's all the same, then random sampling gets you maximum statistical power and flexibility. So always go random, preferably really random, not just haphazard. So really random you can achieve by having, for example, a random number of steps going in a random compass direction, or even better still, devising random points using a map before you go into the field, and then using a GPS to walk to those random points. That's time consuming, but it does give you true random. And then moving on to the final sort of aspect of this, which is how many quadrats do you use? Well, first of all, I would say decide what quadrat size suits your vegetation. And then you've got to decide what's the minimal area of that vegetation that you need to sample to be able to be confident that you've got all of the species or almost all of those species in it. So you sample the whole community. And that's basically, you know, however big your quadrat is, it's the minimal area is all of those quadrats added up together. So what you can just do is do quadrats and increase your minimal area, and then eventually you'll have covered enough of the area to know that you've not getting any more new species coming up. You can see that in a graphical form. Imagine that every time you start with one quadrat and you had 4 species, and then you double it and you get another 1 or 2 new species. Now you've got, say, 6 species, and you double it again, and let's say, oh, another species pops up, so then you've got 7 species, and you're doubling it again, and this time you didn't get another new species, still got 7, and you're doubling it again, and now another one's popped up, so you've got 8. But it's starting to slacken off every time you're getting fewer and fewer species as your new species as your quadrat goes up. And this is how you can plot it. So your total area sampled, so this is like, you know, say like if you've done 4 1 by 1 meters, then that's a 2 meter square. So it's your total area sampled, and it's your cumulative number of species. So how many species have you got? And at some point it'll start to flatten, and at that point that's your minimal area. There's another way of doing this too, which is, so here you go, that just tells you how you'd calculate. If you were using smaller quadrats, you'd have more of those because you fit more of those into a 12 by 12 meter. There's this other way of doing it, which is doing it from a running mean. So what you can do is you can do your quadrats, and these are the number of species in each quadrat. You can calculate the running mean of those quadrats. So that's the mean of that one, obviously. The mean of those 2 is 11.5. The mean of those 3 is 9.3. The mean of those 4 is 11.5, and so on. And you can plot that number against that number, and it will start off really spiky, and it's when it flattens out, then that gets you about that 12 point again. That gets you to your number of quadrats. It's when it starts to sort of flatten, and you know, as you can sort of see, it's probably depends on how rainy it is that day whether you decide there or there, but you can sort of see the general principle. That gives you a ballpark figure of knowing when you've done enough sampling. By the way, if you are using this method, you've got to be fairly confident that it is a homogeneous area. So, you know, you're not actually grading into another habitat, because if you are, then it will keep on going up, and that will tell you actually that you are grading into another habitat if it keeps on doing that for you. So there you go. That's how the basics of what you would need to be able to do to design a sampling method that hopefully will get you data that you can compare robustly and get some nice statistics out of.